Lesson 1.5, Task 1. Investigate properties revealed by different function representations. You can represent a function using a verbal description, a table, a graph, or an algebraic equation. The representations are each good for revealing different properties of the function they represent. Alright, so a verbal description is useful for aiding in visualization and interpretation, particularly when compared to the parent function. The table can help identify or approximate intercepts and key values, as well as reveal any symmetry of the function. A graph provides a quick visual for the approximate minimum or maximum values, intervals of increasing and decreasing for your end behaviors, your x and y intercepts, if it has any kind of symmetry, and any other kind of key values or key characteristics. An equation can be used to find any value given one of the variable values. Alright, so it says 4 different representations of a function are shown. Alright, so what this is 4 different ways to look at the same function. This is the verbal description, the equation, the graph, and the table, and these all are the same function. They're all f of x, they're just written in a different form. So that's what it means to be investigating properties of different forms, okay? So a verbal, equation, a graph, and a table are different forms of the same function. All right, so it says, what are f of negative 1, f of 0, and f of 2? So let's look above. All right, so f of 1, that means negative 1. When your x is negative 1, what is your y value? So we can locate that from the verbal description because it gives us a vertex of negative 1, negative 2. So when x is negative 1, the y value is negative 2. All right, f of 0. All right, f of 0, so this one does not have a 0 here. We probably maybe could identify it. It looks like it goes through a fraction or not a whole point. So let's look up here and see. It doesn't give it to us in the verbal description, but we can plug any value in for x and solve. So 0 squared is 0 times anything is 0 plus 0. So this one's going to be negative 3 halves if we plug 0 in for x. So negative 3 halves would go here. And again, that's just plugging in 0 for our x value. All right, now the next value for x is 2. So I don't see that in the top or in the table. I may be able to see that from the graph. When x is 2, it looks like maybe 2.5, but let's check it using the equation just to make sure. Okay, so I'm going to do 2 squared. It was 2, yeah. Okay, so when x is 2, 2 squared is 4. Half of 4 is 2. And then 2 plus 2 is 4. And then subtract 3 halves. So I've got 4 minus 3 halves is the same as 1.5. So that's going to be 2.5, which is what it looks like here as well. So it does look like that's 2.5. So 2.5 written as a fraction would be 5 halves. All right, and again, that just comes from plugging 2 into the equation and solving. All right, it says explain how to determine each value in part A. All right, so anytime you have an equation, you can plug these in, but because we had the different representation, it was easy to find at least one of these from the verbal description, and it was easy to check this one to make sure it looked correct by using the graph to identify those points as well. So, different ways to use each part of that. All right, how would you find the vertex, the max, the min, the maximum or minimum values, the intervals of increasing and decreasing, and interpret and intercepts given the verbal description by itself? Okay, so just using the verbal description, let's see what we have. All right, the verbal description says the function is a vertical compression of a parent quadratic function by a factor of 1/2. So that means your a value is going to be 1/2. Its vertex is -1, -2, and its end behavior is y approaches infinity as x goes both to the left and the right. So if y goes to infinity, that means my parabola goes up. It turns up, and it has a vertex or a lowest point, a minimum value at -1, -2, and it's a compression. So that would be easy to identify several key characteristics. So the axis of symmetry would be x equals -1. Your vertex would be -1, -2. And that means your x-intercepts would be found by plugging in. You'd have to find the equation to find your intercepts more than likely. But your end behavior, since your end behavior is going up in both directions, that means it would be decreasing on the left, coming down. So it would be decreasing from -infinity down to the lowest point, which is -1. That's your vertex. And then it would be increasing from x to infinity. All right, for the given verbal description, if that is the only information you have, can it be used to describe the symmetry of the function? And the answer is yes, because it's a parabola, because it's a quadratic x squared term, that means that it's symmetric at the vertex. And since the vertex is given, the axis of symmetry is x equals whatever your x value is for the vertex. So I think in this case, I believe it was -1, which I mentioned when we were looking at this. So yes, you can determine that just from the verbal description. All right, for the given equation, if that is the only information you have, can it be used to describe the symmetry? That's the one we just answered, sorry. For the given graph, if that is the only information you have, can it be used to describe the symmetry? Is that not the same thing? Oh, for the given equation, for the given graph. For the given graph, if that is the only information you have, can it be used? Yes, even looking at the graph, you also can tell where the vertex is. So if you can tell where the vertex is, you can see that the vertex goes through -1, -2. So you can locate the symmetry using the graph as well. All right, for the given table, if that's the only information you have, can it be used to describe the symmetry? Somewhat. So the table, since the vertex is on here, it can be used to find the symmetry. You have to be careful though, because this is missing some integers like -2 and -4, and then 0 and 2. In this case, the vertex is identified in the table, and you can tell that from the graph. But if you only have the table, you have to make sure you have the vertex in order to know the symmetry, because again, the symmetry comes from the x value of your vertex. All right, that's all for task 1. If you have any questions, please let me know.